Hi, to all my esteemed viewers, thank you very much for being part of this channel. Welcome to another session from this construction and surveying channel. My name is Buxton. So far so good, we've covered quite a ground in our preparation of bills of quantities. Today I would like us to look into measurement for the staircase. This is a very interesting part. It's a part that is very challenging, and I would like us to do it together so that it won't be challenging anymore. There are those parts of the staircase that needs to be measured. One of them include the waist, another one are the steps, and we also have the landing as part of it. And of course, we are just going to consider the concrete work for now, and then later on we'll do what we call the formwork and as well the reinforcement for the staircase. So let's get started. As usual, we do our estimation and calculations on the Excel alongside the bills of quantities where we are doing our final work, and we show it step by step so that you are able to see how to arrive at those figures. Okay, so first of all, I've said that we are going to measure various parts of the staircase. First and foremost, the very first point of the staircase to consider is called the waist. Okay, so when we are heading towards calculation of the cubic meter of concrete for the staircase, it's normally very important so that we consider what brings the first cubic meter of that concrete. First of all, we have the waist. Okay, so for us to measure the waist, we have to know what the waist is and how to measure it. Okay, normally staircase has got, if I zoom in this one, you are able to see there is that part where you walk on, and that is called the steps. Okay, of course the step is made up of the tread and the riser. Okay, the horizontal one is called the tread. Okay, on this particular drawing where my cursor is exactly, okay, let me just zoom out so that you see the perspective of this drawing. So this is how it is. Okay, of course this is the wall, the external wall to the extreme part, okay, where the landing is. So when I can just show you from the plan that particular wall, so looking at between grid 5 and grid 6, we have what we call the steps. Okay, of course you can see an arrow. The arrow where it's showing upwards, then it means that is now the flight that is going to the upper side. Okay, and then the other one, the opposite part of that staircase, it's going downwards. So the smaller part, the smaller portions, exactly where my cursor is pointing now, those are the steps. Okay, and of course we'll see how those steps are appearing on the section. And then where my cursor now is, okay, between grid 5 and grid 7, that is where we have what we call the landing. Okay, so from one of the discussions, we'll be just showing you exactly these parts of the staircase in just a very short video, so that shouldn't worry you. But then on a drawing perspective, this is how it looks. We have these parts, the so-called steps, the smaller ones. So even if you want the number of those, you can always count them here on the plan. Then here we have the landing. Okay, and then we have that separating wall. Then the wall that you've just seen, that is showing you towards the landing, it's a section cut, for instance, between along grid 6, so that you see the wall that has been shown on the section is that wall coming through grid A1. Okay, I hope you can see grid A1 cutting across that way. But then now the section that we've just seen has been cut along grid, for instance along grid 6. Okay, it can be anywhere in between, but then it's cutting through the steps and as well what we call the landing. That is quite crucial because you need to understand how that is before actually you are able to estimate and take off the staircase. Okay, so that said, we've seen where that wall is, we've seen the landing, and we've also seen the steps. And of course I've shown you that arrow that is giving you the path that is going upwards. Okay, so for instance, on the ground floor, okay, let me just zoom it in this as well and show you. So for instance, on the ground floor, this is how it look like. This is the wall, the external wall that you've just seen from grid A1. Okay, Then this is the tread, I mean this is the landing, which also is always considered as part of the staircase in the estimation. That is also very important. And then now the path that is going upward, we've seen it where the arrow, and then a path that is going the path that is going upward is now following the arrow that is going to the upper side, that is from this very part that is between grade 5 and grade 6. That is now the part it's called the flight. Okay, so we can say from between grade 6 and grade 7 we have what we call flight 1. Okay, and then between grade 5 and grade 6 we have flight 2. Okay, so that is how to identify those flights. So we are getting back to our section, and here it is, so that we are able to now estimate. Okay, so we have flight 1 and flight 2. So whenever we are considering the estimation and we talk about the volume of concrete from the waste, we can subdivide this staircase into three actually. First we have flight 1, we have flight 2, we have landing, and of course we then also have the steps. So which one do we start with so that we get the quantity of concrete for the staircase? Well and good. Where we start with very first is the waste. Okay, so the waste, apart from the top part where we walk on, I mean the steps, just below it we have a rectangular part, or you can call it a cuboid if you so like, because it has got the flat part to the bottom. Okay, just looking through this drawing, you can see that part where we have so I would like to draw a line so that we are able to see the part where there is the waste. First of all, you see the triangular part, the smaller ones, that is what we call those are the ones that we call the steps. But when I try to draw a straight red line here, the part with the reinforcement to the lower part, okay, where we have these reinforcement pieces, you are able to notice that we also have what we call the waste at that point. So the smaller triangular portions, those are the steps, and of course the step is made up of tread, and it's also made up of the riser. So the riser is the vertical one, while the tread is the horizontal one where you step your foot on while walking on the staircase. And then now the part that I've just drawn the line is what we call the waste. So we need to get the volume of concrete in the waste, that is one. Then we need to get the volume of concrete on the steps. Okay, and of course we do the one for the landings, and thereafter we'll be complete, or will be done with the estimation of concrete in that point. Okay, so we label here staircase. Okay, yeah, of course, any of the new viewers finding us for the first time, you are in the right channel. For any of the catch-up videos, just search into the description button of this very video, then you'll find it. Actually, you have it there as a playlist where you can catch up with all the videos that you need for preparation of Bills of Quantities. So there is absolutely no worry if you are getting us for the very first time. So let's continue. So this is the staircase. First of all, we look into the waste. Okay, so we have got two flights, so we can actually talk about flight 1. Yes, normally you can subdivide them if at all the flights are different, but if the flights are the same, then you can just do one flight and multiply by 2. Okay, so we go with the waste. Actually, we can just leave it alone that for now. So this we can call it flight 1 and 2. Okay, and then we talk about the volume of concrete for the waste. So waste is that straight part that is below the steps of a staircase, where we will draw the red line along. The volume should be length length times width times the depth. Okay, where all these parts mean the length is the longer one. Okay, the length should be where along the line that we've drawn exactly. Okay, so that length going all the way should be the length of what we call the length of our waist. Okay, and then how do you get the width? The width should be gotten from this plan. Okay, so in this case, flight 1, it will be the width is going to be between 6 and 7, that dimension. Okay, of course you'll see when we add now to the external part so that we take it all the way. So let's see that. You can also notice that for the length it's slanting. So when it's slanting, then it means we have to get it that length by calculating the square root of hypotenuse squared plus base squared. Okay, so in short, what we are trying to find here, I want to show you that we have let me just draw this. We have this kind of shape. Okay, we have this kind of shape. Just we have that triangle. Okay, so having noted that, I just want to stretch this so that it's complete up to there, and I also want to do the same. Let me just stretch this one up to that point. Okay, so we have this complete triangle. The area that we need for the waist is let me just show the length that we need. So this is where we have this is the waist. Okay, it's important that we know these parts. We have this as the waist. Okay, and of course now the steps. If I can just stretch my arrow down a bit as well so that it's clearer. Yes, so this is where we have the waist. Okay, so the length is now the horizontal slanting dimension. So for us to get that, we have to get what we call the height. Okay, so our height is supposed to be this one, while this is supposed to be base. So using Pythagoras theorem, we should be able to get now this length that we are calling the waist at this point. Okay, all right, so how do we go about that? How do we know about the height, and how do we know about the base? So for us to get the height, you can see the height, there is a distance that has been given called the ceiling height. Okay, made up of the risers. For instance, you can see here we have 20 risers at 150, each of them at 150, giving you a total of 3000. Because the risers are vertically from the finished floor level to definitely to the ceiling level, then if you add those heights, then you're supposed to get the height that is going vertically from the floor level. So what I'm saying is, for us to get the height, we can get this vertical dimension right from the floor to the ceiling. So in this case it's 3000. Okay, but we need to consider the waist per flight. Okay, so this is flight 1, and then the other one here is flight 2. So for flight 1, when you now get that particular length, we're supposed to get height. So what is that height? That height is supposed to be half of the total height from the floor level to the ceiling level of the next floor. So this is 3000. Okay, 3000, we divide that 3000 into 2 equal dimensions. So it means halfway is supposed to give us 1500 for the height. Okay, it means the total is 3000. You can see it's 3000 here. For us to get just the height of one of the flights, then we divide 3000 divided by 2, we get 1500. Okay, so the height of one flight, this is the first flight, the height of one flight is 1500. Okay, then we go to the base. So for us to get that base, let me just let me erase what I wrote here so that the drawing is also clear. So having deleted that, then we need the base. This base is supposed to be equivalent to the summation of the threads, the length of the threads from the bottom here to the top. Okay, this is thread 1, this is thread 1, this is 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that tells you that for us to get this base, it's equivalent to the total of the thread, the length of the threads from the start to the finish of that particular flight. So thread 1, thread 2, thread 3, and so on. So what we simply need to do is simply get the length of thread, I mean the width of one thread. Okay, that is from for example here to this point, we need to get that length. Okay, we need to get that length, and then we multiply by the number of threads. That is how to go about that. So let's check if at all we have the threads mentioned anywhere. Okay, so let's get a straight line. I can see there's a dimension indicated here. We have 9 threads, each at 300 millimeters, giving us a total of 2700. But as usual, we always confirm. If I draw that straight line all the way from the top, and then I draw another one all the way that way, so that you are able to see what I was talking about. So this straight line, the 2 red lines that I've just drawn now, there are 9 threads. Can we confirm? 1, 2, 3, 4, 5, 6, 7, 8, 9. The last one there, the one where we started with. So there are 9 threads. Each thread is 300 millimeters. 9 times 3 gives us 2700. So we have a base that is 2700. Okay, so our base is equal to 1 thread times the number of threads that we have for a single flight. So in this case, we already have the waist. The length of the waist is supposed to be now square root of the base squared, which we have gotten to be 2700 squared, and then we add 1500 squared. Okay, so this is using the Pythagoras theorem rule. The hypotenuse, which is equivalent to the length of the flight, is supposed to be base squared, which is 2700 squared, plus 1500 squared. So let's get to our Excel and sum up that one very fast. So once we have that, the flight thread, we'll get the length, and then the width we get from the plan, and then the depth is indicated here in the notes. Okay, there is a part I've seen, waist is equals to 150. Let me see. Yes, there is this line here. You can just undo all that I have written, or rather just get my selection and then delete that selection. So there is this part that is telling you section through staircase, 150 millimeters thick for the waist. Okay, so the 150 millimeters thick, it means it's from here where we have our step starting up to the bottom. Okay, so the all of it is 100 and 150. So we can get the length by using the Pythagoras theorem. Hypotenuse is equals to base squared plus height squared. get that length. And then we get the width from the plan, and then we get the depth from this detail that has been given. So if you have all that, then you can comfortably get the cubic meter for concrete of every flight. So we continue with this. Therefore, first of all, let's get length of the waist. Okay, we've started with the waist. First of all, we get the length. Okay, so length of the waist is equals to square root of hypotenuse squared, which is supposed to be this one. Let me see if you have that symbol. All right, so hypotenuse squared, what did we get? I mean height squared, we got it to be 3000 divided by 2, so it's 1500 times 1500, and of course we add the base squared. So base is equals to single thread, which is 300 times 9. That has been already done in our details, and it's giving us 2700 squared. So it's 2700 times 2700. Okay, so that gives us a total of that figure. So we need to get square root of that. Square root of 954. Oh, the figure is quite big. Let's see what we have. Yes, so that gives us a square root of 9.54 million. So the square root of this is equals to 3089. Okay, 3.089 meters for the length of the waist. Okay, I'm repeating that waist, the length is equals to the hypotenuse of that triangle we drew, and for you to get that, you get square root of height squared. Height is the total of the ceiling height divided by 2, height squared, plus base squared. The base is equivalent to the thread of one of them times the total thread for every flight. Alright, so we have that. This is supposed to be 3.089. Then we talk about the width. Okay, I'm talking about the width. Width, you go to the plan. Okay, this is the plan of a single flight. These flights are identical, so we'll just do 1 multiplied by 2. For a single flight, the width is shown here to be 1200. Okay, for the 1200, I always recommend that we take that length to the external part. So 1200 is to the center. Okay, so we'll take it from the center, that is from grid 6, but then we go all the way up to the external part of this particular wall, and this wall is 200, so we add 100. So it's 1200 plus 100 to the external part here, so that gives us 1300 for the width. Okay, so this is 1.3. And then we get the depth. What is the depth? The depth, get to the details of the staircase. You will always have it indicated somewhere on that drawing. That depth is showing, that depth has been indicated somewhere here. It's 150 millimeters depth for the waist. So this is 0.15. Okay, so the volume here will be that the way just we've indicated here. It will be length times the width and then times the depth. Okay, so this is the volume of concrete for a single flight on the waist. Okay, so for 2 flights is equal to the volume of 1 times 2. Okay, let's leave that at that point. Then we talk about the next one is the steps. For us to get the volume of the steps are triangular. Okay, so these are the steps, and on the section point, the step, this is one of the step. Okay, step is made up of the tread and the riser. For us to get that volume, then we are supposed to get that volume of that triangular portion going all the way. Okay, so what we need is the length. Length get from the plan, and that length, looking at this plan, these are the steps, and the length of the steps is equivalent to what we had as the width of the waist. So this 1200. Of course, we are also going to take it to the extreme parts, so that is 1.3 meters for the length. Then the width is equivalent to the tread. The width of the tread is the width of the step. And of course, the depth now is going to be equivalent to the riser, because when you look at this particular drawing, this is what we are talking about. Okay, this part here. So the length is from the plan, we've got it to be 1.3. The width of it is equivalent to the tread, and the tread has been indicated here as 0.3 meters. Okay, 300. Okay, and then the riser is indicated here as 150. Right, so the step length is equals to the length that we had calculated for the width that we had calculated for the waist, 1.3, and now the width is equivalent to the tread. Okay, width is equivalent to the tread, and each tread is 0.3 meters, and then the depth is equivalent to the riser, and the riser is 0.15, 150. Okay, so we can just indicate here for emphasis, length is equals to width of flight. Okay, and then the width is equivalent to the width of tread, and then the depth is equivalent to width of riser. Okay, then we are supposed to now calculate the number of those steps. How many are they? Okay, so this being an identical staircase, we can count on any of them. Okay, but I would like us to count from this first one and see how that exactly goes. Right, so we have, this is 1, this is 2, this is 3, this is 4, this is 5, 6, 7, 8, 9. Those are 9 number treads, 9 number steps. But normally there is this hidden portion here, which is normally not catered for anywhere. So there is that volume just from the step, between the flight, between the waist and the floor, there is a portion of concrete that is there, equivalent to what we have as the step above. So we count the one above and then we add that one. Okay, so we have 1, 2, those are 9, plus 1 gives us 10 steps. Okay, so on each flight we have got 10 steps. So the volume, this being a triangle, volume is equals to a half, 0.5 times the length times the width times, that is now the width, and then times the depth, so that we get the volume, times the number of the steps. Okay, so that gives us the volume of concrete for only one flight. And of course we now take volume for one flight and then we multiply by 2. So for every floor, so the total volume of concrete for the whole floor we've done for the 2 flights, and we've done for also we've also done for the steps on all the two floors. So that gives us a total of 1.7898, so on. So once we have that, that is now the volume of concrete of flight, for the two flights. That is just for one floor. That to mean it's the volume of concrete for the waste, all the waste of one floor, and also the steps of one floor. But we are dealing with a high-rise building, and they are identical. So it means once we have the volume of one, then we multiply by the number of floors which are available. So let's see how that goes. So how many floors do we have with staircase? Okay, so where do we go? We go to the section of let's see. So we need to confirm, this is a section through the building. We need to confirm how many floors does it have in terms of the staircase distribution. So this is what we do. The first floor, we've dealt with the first floor where we've done the flight separately, and we multiply by 2. We've also done for the steps. So this is 1, 2, 3, 4, 5. So we have 4 number floors that are identical in terms of the staircase flights and as well the steps. So the total is equals to volume for one floor times 6 number floors. Okay, so that is what we have. Actually there are 5, not 6. So this is 5. Perfect. So that gives us a total volume of concrete for all the floors, and that is how to go about that. Alright, so that is a cubic meter, and we've done it that way. Then we have what we call landings. Landings, you do the volume, the concrete is measured in square meters. So when we need that square meters, then we go to the plan. We go to the plan and be able to calculate that. So this is the plan. From the plan, you can see the landing is here. Just draw it here so that you see it. That is how it looks like. Okay, so that means we have the combination of all the width of both of the flights, that is 1200, then we add 1200, and I always recommend that you take it from the extreme end. So you will add 0.1 to the top and another 0.1 to the bottom. So that is 2400 plus 0.2. Okay, that is 2.4 plus 0.2 gives us 2.6. And of course we need now the width. Okay, so let me just undo what I've indicated so that the drawing is clear. So for the width is from this point to that point, and it's as usual when you go down to this point you can see it's 1200, that is from grid B1 to A1, 1200, but the 1200 it's at centers of the wall, so we also add 0.1, 0.1. Alright, so the landings length alone of one of them is equals to 1.2 times 2, then we add 0.1 times 2, and then the width is equals to 1.2 plus 0.1 times 2. I always recommend that you take it from extreme parts. So the area of one flight is that, but then for all the flights is equals to that, and then you multiply by 5 number of floors. So this is the area for the flight of concrete, and the other one for the staircase and the steps is 8.948. Alright, so the next work remaining is just to put it in our description, and then we are good to go. So let's see. Superstructure concrete work, we have this. So this is item F. So we have staircases. So the description is normally just indicate staircases. So that would mean flight and the steps. And the unit here is cubic meters. What we've got is 8.9. When you round it up, it's 9 cubic meters. And then we also have this is now G, 150 millimeters thick landings. Okay, that is done in square meters, and the area we've got is 18. We've got an area of 18.2. That is 19 square meters. Okay, so that is what we intended to cover. We intended just to break down the measurement of concrete in the staircases quite well, and I'm confident that you've really understood how we've done it. There is always a chance to recap of all this so that it's even very more clear than we have done it. So we've done for staircases, for a story building, and we've also done for all the landings, and that should be enough for now. Thank you very much for keeping watching up to this point, and I'm confident that you've learned a lot from it. Any question that you may be having, please put it on the description button there so that we attend to it and you're able to also learn even better. Thank you very much. Please stay tuned. Before you leave the channel, for the new viewers, kindly subscribe. You don't want to miss any of these upcoming videos because they are very elaborate and you will benefit a lot from them. Have a great time till we meet again in our next session, where we are now going to do reinforcement for these items that we just covered. Thank you very much. Have a great time till we meet again in our next session. Bye bye.